So it's a great pleasure to be here. I'm Shunsuke Okada, the Executive Committee of the Q-Star, the consortium established by Japanese industry to use quantum technology to promote new industries and business. So I'm also a Corporate Senior Vice President at the Chief Digital Officer of Toshiba Corporation. So I'm happy to say that Japan's contribution to recent progress in the quantum computer developments. So 5 foreign companies were ahead in the quantum computer development. Japan's first domestically product quantum computer went online last March. Early this year, a Japanese consortium announced the technology breakthroughs on error to tolerance and noise-insensitive quantum computing. This is expected to accelerate further developments. So we still await development of the gate-type quantum computers. So in the early stage of the industrialization, we will rely on Ising machine, also known as annealing types. They are dedicated to contribution optimization problems and are expected to bring the quantum technology into many areas. With Ising type, we are seeing a growing practical use of the algorithms described as quantum-inspired. They emerged from studies of the quantum computers, but run on the conventional digital computers. As you can see from the names of the left, this is the area where Japan is strong and hopes to advance progress in the quantum industrialization. Already, quantum-related technology has started to find real-world application. Q-Star member companies have brought into logistics, manufacturing, finance, and more. So as you can see here, in 2023, many countries and regions formulated policies on the quantum strategy. The growing global interest in the quantum is clear. In Japan, the Cabinet Office published its Vision of Quantum Future Society, which complements Japan's quantum technology and innovation strategy in April 2022. Q-Star participated in the review working group. The vision calls for 10 million technology users in Japan by 2030. Q-Star also contributed to strategy of quantum future industry development, published by the Cabinet Office last April, which targets achievement of the goals of the vision of a quantum future society. This year, Japan is moving on the next phase, discussing on the promotion measures for the development of quantum industries. At this point, globalization is now added as a perspective for particular application and industrialization of the quantum technology, alongside collaboration, incubation, and accessibility. So from here, I would like to focus on the Q-Star. Since its established in 2021, the consortium has worked closely with the Japanese government by participating in the working groups on the Japan's quantum technology and innovation strategy, as I already noted. The organization now has close to 100 members. In its first year, it's identified created quantum technology use cases. We have identified more than 50 and selected 16 of those as the basis of the roadmap of quantum industrialization. So for many members, the main reason for the joining Q-Star is participation in the subcommittees at working with our diverse membership to create use cases. The executive committee now has 8 working groups and 6 subcommittees that create use cases. Promotion of SDGs with quantum technology was just established this April, reflecting on a strong aspiration of the membership. So last year, the Japanese government established GQuad as an international industrial hub for global companies and startups to advance quantum business development. To make use of Japan's strengths in Ising type algorithms, we need to develop an environment that brings quantum and classical technologies, advanced cumulative verification in a hybrid environment. Q-Star will work closely with GQuad on that, and Teisan, of course. So another focus in the Q-Star now is discussion on the open software platform for building a quantum computing ecosystem. This is the structure of the software platform currently under discussion. It visualizes software as a hierarchy. Customer issues which may or may not be quantum are the top. The middle levels in the software hierarchy. The bottom row is made up of different computer hardware, including classical quantum annealing, NISQ, and FTQC. The flow of the problem solving from top to bottom. A characteristic of this approach is that the problem solving method is not imitated to quantum. It is a hybrid approach that combines the best methods for the solving customer problem. So at the global level, Q-Star participates and communicates in the workshop with consortiums around the world, working closely especially with QEEC and QEDC in the US and QIC in Canada. In January last year, we joined them in the signing a memorandum of understanding to formally establish the International Council of Quantum Industry Associations. Our main scope takes in the shaping information on events in each region, providing R&D opportunities across countries and regions, and collaboration in the areas where signs can be expected. We are now discussing global supply chain, quantum ecosystems, standardization, and the possibility of the international symposium. So now please let's introduce Toshiba's quantum-related business we are already promoting. So today, communications are generally secure because it takes a huge amount of the computation to break encryption. However, when the large-scale quantum computers appear and their immense increasing in the computational power become available, the encryption that now protects communication security will be easily broken. Once that can be done, it is possible to intercept, decrypt, and exploit communicated information. Even if the data cannot be decrypted now, there is a risk of the data harvesting, where encrypted data is collected now for decryption after large-scale quantum computers become available. So in order to deal with those threats, Toshiba developed the quantum key distribution, QKD, for the new age of the secure communication powered by quantum physics. QKD is used to distribute the secret digital keys needed to protect highly sensitive data critical to many industries. This is particularly important for data in the finance, defense, utilities, and healthcare, and so on. So this sense of the QKD security relies on encoding transmitting each bit of the key on a single photon through an ordinary optical fiber, for example. As any attempt to read to photons alters their encoding, this allows to the security of each key to be tested and guaranteed. Unlike other existing security solutions, QKD is secure from all future advances in mathematics and computing, including the data processing power of the computers. So here are some of the recent collaboration in the use for our QKD technology. So in the UK, HSBC, a major global finance institution, has joined BT's commercial quantum secured metro network in London. In France, we verified a multiplexed transmission over the existing fiber network with Orange. This shows that we can enable quantum key distribution along the current data services. In Japan, we have secure full demonstrated IPsec QKD VPN communication and optical wireless communication with SoftBank. We will continue to promote social implementation of the QKD with partners in each country. So, inspired by quantum technology, SQBM Plus is an optimization solution developed from the simulated verification machine. The combinational optimization solver built on the simulated verification algorithm developed by Toshiba. Through collaborations and co-creation with expert partners, we are contributing to solutions to deeply complex problems in areas as diverse as finance, drug discovery, genetic engineering, logistics, and AI enhancements. So SQBM Plus version 2 was released from AWS Marketplace and Microsoft Azure Marketplace last autumn. In addition, Q-Star's Amplify, its Japanese startups companies, has built and released an on-premise version of the SQBM Plus in its own data center. Also, in spring this year, StrangeWorks, a globally quantum platform startups, released a SaaS model of the SQBM Plus. We hope that many more partners will deploy the SQBM Plus global ecosystem platform in the future, of course, in South Korea. So, use cases including finance, factory shift optimization, drug discovery, black box optimization, clustering, factory picking, route optimization, etc. SQBM Plus is working with various companies and partners to apply S2 into industry ecosystem. So I'm sure we all recognize that the coming age of the quantum computing offers all of us many opportunities for the new age of industrial competitiveness. And I hope we can work together at the global level to achieve its promise. So thank you very much.